255 megahertz, 95 gigahash. Not perfect, but hey, I've got an actual test system going here. One chip in a socket. Let me show you what I'm talking about. Hi there, welcome back to the channel. I'm Brian, and on this channel we work on fixing Bitcoin miners, primarily S17 series hash boards. However, one of the big questions I always have when I'm working on them is, are the chips I'm using any good? Yes, there's a voltage test you can watch to see how much current gets pulled through a chip, but what if there was a little unit you could put the chip in and it'd work? Maybe a unit that looks just like this. So what you're looking at there is you're looking at the Bitaxe Test Socket version. Totally a prototype. Don't jump online and think you can order this from your favorite mining supply place. Now, there are chip testers listed on AliExpress somewhere between $700 and $1,000, zero documentation, and I don't know what they do. And all the sellers can't tell me what they do, but they've got a fancy little socket similar to this one. All right, so they got this fancy little socket just like this. They don't have the heat sink, and they got some buttons you push them, but that's not what this is. This is ASIC miner, fully open source, built on the Bitaxe project. The link to the main GitHub will be in the description down below. If you didn't see last week's assembly over on Decentral, Raz did a phenomenal job of putting all the parts on there and showing you how to solder it and basically get a Bitaxe ready to go. At least up to the programming point. Thanks so much for Decentral, because I lost all of my assembly video and I really did not want to have to go back through and reshoot all that. So you can go watch them. Raz did a better job than I can do anyway. All right, so let's get into this. What are we talking about here? So this is the Bitaxe test socket version. By the time you watch this video, the test socket branch should be on GitHub, and if it is, there'll be a link to it in the description down below. If it's not already checked in as a PR, then I'll have the link down below to my GitHub repository if you want to get started on this yourself. Before I go any farther, I want to actually make sure I give a huge shout out to Scott, the inventor of all this. At least it's in his repository. Johnny9, who's been doing an amazing job on getting the ESP32 miner software going. It's making leaps and bounds every day, and I've been playing with that, as well as all the other great people who have contributed and given me ideas and helped me troubleshoot getting my boards working. So I want to say a huge shout out to everybody in the Discord channel that's been kind of involved in this. If you are considering getting into this and building one of these or building a few of these, then by all means jump on the Discord channel. Don't just depend on the discussion on the Bitaxe GitHub page. Forget it. Get into the Discord channel. Link to that will also be down in the description below. All right, let me give you a real good up close view of the parts. So let me get to the microscope. Okay, so I'm going to start off with the little OLED screen. Now, this is, you don't have to have this screen, but it's really handy, and I bought a pack of 4 of these for 12 bucks. But I'm running on, so the ESP32 microcontroller is running the I2C test image, right? So you just load that on, and then it runs and it tells you what's going on. So you've got the fan speed, you've got the temperature, you've got power, and then I modified the code because that's the beauty of open source, and I moved the decimal places over because I don't know why Scott likes milliwatts and milliamps, but I like actual amps and watts. So here we can see that right now this chip is pulling 8.1 watts at 1.62 amps. It's running on a 5-volt power supply. Okay, so that is the beautiful OLED screen. There's the ESP32S3 wireless controller. Now, right now, you've got to do, if you want to do anything with it, you've got to compile all your settings very statically. You load them and so forth, but work is in progress. It's already talked about how we're going to, I say we like I'm going to really contribute. I'm not a C programmer, sorry. But everybody in the community that's working really hard, they've already figured out, hey, we need to be able to save our settings. So there's talk about integrating an SD card in a future build. So once we have that, then we can start saving things. So what you have here is you have a fan header and you have your UART connection. Basically that would be your serial. Transmit, receive, ground, and RST. Now the reason why we need the RST is because Scott modified the CG miner code to raise the RST and do a reset on the chip. Finally, right over here, you see my FT232 USB to UART controller, right? You can also get a 230 controller. So that little jewel right there, you only need these if you're planning to control the board with CG miner like I'm doing right now. If you want to use just the ESP32 microcontroller and use the ESP miner software, which is being developed, it's not full bore yet. But if you want to use that, then you don't need these little USB to UART adapters. So you can see you've got your transmit, your receive, your ground. Oh, RTS right there. So you basically just need those 4 connectors right there and you're good to go. So you'd use one of these two, right? If you wanted to drive this with CG miner like I'm doing today, you'd use one of these two. There are a lot of resistors and components on this system. I want to say about 62, 65, somewhere in there. A lot of things to solder. But let's go ahead and take it all apart. I am gonna leave my little makeshift risers, so I'm gonna leave those attached. So the real key to this entire project really is the test socket, right? Because without the test socket, you have to solder the chip on every time, and that's not a very good way to test chips. So you can get this socket from Thanos Mining. That's the cheapest place I've found it. You can find it on AliExpress, but you can find it cheaper at Thanos, even with shipping and everything, and their new stupid handling charge. The link will be down in the description below. If you want to order one of these, you might want to order 2. I mean, hey, if you're going to build one, build 2. I mean, you're going to end up with 5 boards anyway. Now, when you get it, it's going to come with this black plastic insert to hold the chip down. There you go. So see, it's just plastic, right? And the problem with that plastic is that it doesn't conduct heat. And so if you don't have some kind of a heat sink on this unit, the chip's going to get overheated very quick and you're going to cook your chip. So you don't want to just use that. That's where my buddy John helped me out. So when you get a retired machinist / computer nerd / just overall smart guy, I gave him the black part, right? I said, hey, this is what I need. Make it poke up through here so we can mount a heat sink on the top. This is what he created first run, right? Now this is not, super finished product. In fact, he even thought he might have to do some stuff to it. So you're going to need one of these. No, I'm not going to give you John's information because he told me he's leaving town. Even if you could contact him and talk him into building one of these for you, you wouldn't get it till next year. However, he is going to be gracious enough to create as-built drawings. You can get this thing machined or 3D printed at one of the places that do that kind of work. So you'll need this, right? I don't know if we really need this big of a heat sink on here because I just don't know if we really need it. All right, one more thing I should mention before I keep going. You'll see these little legs here. You can buy these for Arduino project boards and so forth. They come in 40 pins. Just buy a pack of those off of Amazon for like $5, and then you can install them yourself, because the board's going to come with just the nice little holes. It's not going to have the pins. Likewise, the socket here, you buy that when you buy the pins. Again, Amazon. I'll make sure the links are in the description down below for those. Let me show you this before we get too far. I want to show you how the chip socket works, just in case you've never seen this. So the idea is, obviously, it's got basically a bed of nails. And what you have here is you have a floor that when you drop the chip in there and you press down, the floor goes down and the pins come up. But not only that, but you also have the pins themselves are spring loaded. So they're going to push with just enough pressure to make contact. Now you may notice, the sharp-eyed viewers out there may notice that this pin is missing. What actually happened is I broke one of the other pins, and that pin's not used for anything. So I disassembled this entire unit and moved the broken pin out of the way, and I took this pin right here, I moved it into the spot where I broke the pin. So yes, you can disassemble the whole thing and it will still work. It's actually pretty neat how those are just spring-loaded pins. But that is key. The floor drops down when you set the chip in it. So here's a chip that I want to test, right? And so you just need to make sure you orient pin 1. I marked pin 1 up there. You drop it in, put it in place, just like that. And then whenever the top comes down, it'll press on this and that'll push it into the pins. Just like that. Now I have found that I need to put just a touch of thermal paste on here. I've not tried a thermal pad yet. And maybe a thermal pad will work. I just haven't had a chance to dig out my 0.5 millimeter ones and see if they would work, because that would be, I'd want the thinnest one possible. Now you do need to be careful when you're using this, because you've got such a big mass on there. You could essentially crack the chip if you go torquing on it really hard. So just something to keep in mind. All right, let's talk about the circuit itself. So the default circuit actually has the original Bitaxe circuit actually has the chip placed right here, and you put then you can put the CPU type cooler on top. But that's the soldered version. We want the non-solder version. So that's where these rails come in. You have two rails. You'll have to cut them to fit. Nobody's going to give you a what is it, 19 pin connector. So you know, just get the 40 pin and cut it down to size. Very simple. Okay, this is one of the two headers that you'll need for the programming of the chip. This is the other one. There's where your OLED plugs in. On the bottom side, you got your two MOSFETs right here. Let's go into the microscope. All right, so looking underneath, you got your ground, you got your input, you got a nice little controller there that actually measures the power consumption. So that's what we saw on the OLED. You have two MOSFETs. Now, unlike for those of us who are used to working on our hash boards, they're using these MOSFETs to switch the power and change the voltage. Our MOSFETs on our hash boards don't do that, right? Our MOSFETs just turn the power on and go. So these MOSFETs, you can see there's pin 1 on one MOSFET, there's pin 1 on the other MOSFET. So pay attention when you're assembling the board. And then here's a nice big inductor. You got some capacitors. This is all your 1.5 rail right here feeding the chip. Now this is, I want to show you this. So this is the power going into the chip from the board, and you'll notice this really small trace right here. I have beefed up that trace, so it should be better when you order your boards. So far it hasn't been a problem. but I went ahead and beefed up that trace on your boards that you can download and build yourself. This is what I want to point out though. For those of us who repair boards, this U1, this oscillator here, that is the same oscillator. In fact, I took mine off of an F17 Pro board. It's a different part number than what's spec'd in the schematics, but it will work just the same. Other thing, just so you know, make sure you'll see, if I zoom in, you'll notice that I have removed R23. Make sure you remove R23 or just don't place it. I don't want to talk about how many hours. The deal is R23 and then R2, I think. So these two 0 ohm resistors, they basically feed the clock of the chip through different means, right? R2 feeds it from the oscillator, and then R23 is going to feed it from a IC. And the ideal being, we can remove that R2 and put the R23 in there, let that IC run, and when it does, we should actually be able to vary the clock frequency. All kinds of cool things are coming in the future with that. So anyway, that's why I left the resistor so I can just push it right back into place. So let me put it back together and let's see if it runs. Oh, before I forget, if you look at the circuitry, you can build this so that you don't need the microcontroller and you just run it off of CGI or CG miner. You could totally do that, right? But if you want the whole concept of eventually a Wi-Fi based little personal miner that pulls less than 15 watts, and ideally it's going to get up to 400 gigahash, maybe not with a socket based system, but definitely if you solder it on there, you can get a new chip should be able to get you to 400 gigahash. If you're going to get into this and start building this, you're going to need this little ESP PROG board. Okay, and now this board comes with 2 cables, but you're only going to be able to use one of the cables. Okay, and so what you got there is you got the J tag. That's the one that plugs in to here, and it basically it's like the serial interface, right? It lets you view what's going on the microcontroller. However, if you're going to program it, which these things don't come programmed, you're going to need this cable. And when you buy the cable, buy the little bitty holder, right? So I'm not excited about the fact that this cable and holder cost about 50 bucks plus shipping, but you need it, right? I guess if you wanted to, because you're going to have the design files, if you wanted to, you could change out this little spot. That's where that special cable goes through. If you wanted to, you could change that out with a header pin, and then you could just use the other supplied cable that comes with your ESP programmer. Programmer is about 30 bucks. So it's up to you if you want to redesign this. I'm trying to keep this the way Scott designed it because, well, I bought the cable, so I don't need to save money now. All right, so let's get this thing back together. All right, my board is short, so I had to notch out the plate a little bit. The design that's now in GitHub, I moved all of this down 7 millimeters, so that should more than clear this. And if you build it and it still has clearance problems, just let me know that it still needs more, and we'll expand it some more. The big key is there is a white dot on the board, and you want to look on the Thanos board and see where that number 1 is. I found an Xfinity 5 volt 3 amp. I cut the ends off. It had a USB-C on it. Honestly, I think you could put a USB-C connector here. You'd have to change the pad layout to support it because USB-C can support 3 amps. There is no circuitry in this to protect you from being stupid. So if you reverse the polarity, I think it will probably mess up the circuit. All right, let's see what we need. We need our fan. So let's get our fan. Now, I'm still playing with this. This is a little 80 millimeter fan. You need some kind of airflow. I don't think you need like ASIC miner level fan, okay? You could try it, but I don't think that's really necessary. And you kind of want something that's quiet. Now, keep in mind that the fans on our ASICs are 12 volts, and this is a 5-volt header pin. So make sure that you're getting a 5-volt fan and not a 12-volt fan. CPU coolers are a good example of a 5-volt fan. We need to plug in our UART, right? Now, here's the thing I want to point out with the UART connection. So as you can see, you got a transmit and a receive, right? TXO and RXI. So the TXO actually connects to your RO pin, and the RXI connects to the CI pin. So you actually need to, just like anytime you're connecting, serial type devices, you need to remember to switch. So transmit on the Bitaxe board needs to go to the receive on the UART board, and the transmit board or transmit port on the UART needs to go to the RX on here. See, let's put this over here, right? So see, I've got the RXD and the TXD. So the receive would get the TX from the Bitaxe, and the TX on the UART will get the RX. So don't mess up that one. Now I just used, I have a little pin kit, right? And so, just these are project wires. I put them in a 4-pin so I don't have to mess with them. Let's go ahead and give it the power. You'll see the little OLED come on. There we go. There's something I forgot. We're missing a chip. I'm just grabbing chips that I've cleaned up, that I've pulled off, and these chips are actually coming out of my suspect bag, right? So I had all these chips that I didn't think were really good, and so I've been putting them in and testing them. I will say that you need just a dab of heatsink grease. Now, you don't need to use it every single chip. It'll get built up on here. There you go, just a little dab, not much. It lowers the temperature a good 10-20 degrees Celsius. All right, let's go see what we got. I'm gonna give it the power. You'll see the OLED screen come on. Okay, and then I'm going to plug in the USB. Cool, there we go. Hot plug. So we're treating this like it's a Gecko Science unit. You can see that it actually found the chip. See, it's saying right there, GSF0, and it is going to work right now. Oh, look at that. So ASIC plateau. Now, when I see this, it tells me that, or the way I'm treating it right now, is that if I get a chip that can't even hash at 220 megahertz, then the chip is probably sus. It's probably not good enough, right? It's a weak chip. That is the Bitaxe Test Socket version. So if you want to build one of these, I encourage you to try it. They're really fun. Keep in mind, this is not a finished product, right? This is an open source project that's pretty early. It's pretty young, but you're going to find some, or at least I have found some really cool things. I learned how to better use my oscilloscope working with this. I learned more about reading schematics from working on this. So if you have the time or you have the inclination, by all means, download the files, go to somewhere like JLC PCB. I priced it out. The minimum order of boards is 5, and it'd be about $50 with shipping to get 5 boards sent to you. And then the parts, well, it just depends on, do you buy the parts for 5 boards? Or do you buy the parts for 2 boards? That all depends on you, how much you want to spend. I know there's also work going on to have it so you can get these boards assembled with all the parts placed at JLC PCB. If I see them swapping out parts to make it cheaper, I'll keep this design updated. If there's something you do with this board and you would like to see it, by all, change to make the board better for other builders, by all means, please do a PR Let's talk about it. Find me on Discord. Find me in that group, right? I'll have a link to that Discord channel. Let's just go back one last time. There you go. Look at that. It's sitting there hashing. It's climbing, right? 260 megahertz. This may be the super chip. This may get itself up to 300 megahertz. That'd be cool. I don't know. I think there's some limitation just with all the mechanical connections. That's pretty neat. 58C, 8.37 watts, 1.6 amps. Right now, your 1 minute average is 83 gigahash. You're not going to set the world on fire with that, but with a little bit more tweaking in the right chip, you could run 300 or 200 gigahash, less than 15 watts, and set it on something like CK Pool Solo, and you could maybe win a block. It certainly won't cost you as much as running a S17. If you haven't already, give the video a like and subscribe if you're not a subscriber, because that really helps the channel and it helps to make sure that other people that are interested in this find this channel. Links to everything that I talked about are down below. Thanks for watching, and I'll see you soon.